Hello everyone, welcome to AAT concept video. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is computer science engineering with data science as specialization. Today my subject is database management systems. My topic is write the different types of steps in developing ER model. So let's start. So I mainly divided the content into two parts. In the first part, I'm going to discuss about the ER model, the basic idea about the ER and its relationships. And then in the second part, I'm going to discuss about the different types of steps in developing ER model. So let's begin. ER model, the basic idea about ER model. ER model stands for Entity Relationship Model, also known as High Level Data Model that shows the relationships among the entity sets. ER model is used to define the entities and the relationships between them. It helps developers to design the conceptual design, or you can say the logical design of the system from a data perspective. ER model describes the structure of a database with the help of a diagram, which is known as the entity relationship diagram, ER diagram. ER diagrams are used to sketch out the design of a database. By defining the entities, their attributes, and showing the relationships between them, an ER diagram illustrates the logical structure of databases. ER diagrams are created based on the three basic topics. They are entities, attributes, and relationships. So ER diagrams are visual tools that are helpful to represent the ER model. Peter Chen proposed ER diagram in 1971 to create a uniform convention that can be used for relational database and networks. He aimed to use an ER model as a conceptual modeling approach. Here are prime reasons for using the ER diagram. It helps you to define terms related to entity relationship modeling. It provides a review of how all your table should connect, what fields are going to be on each table. It helps to describe entities, attributes, relationships. ER diagrams are translatable into relational database tables, which allows you to build databases quickly. ER diagrams can be used by database designers as a blueprint for implementing data in a specific software applications. The database designer gains a better understanding of the information to be contained in the database with the help of ERP diagrams. ER model allows you to draw database design. It is an easy way to use graphical tool for modeling data. It is widely used in a database design. It is a graphical user interface representation of the logical structure of a database. It helps you to identify the entities which exist in a system and the relationships between those entities. Entity relationship diagram symbols and notations mainly contains three basic symbols, which are rectangle, oval, and diamond, to represent relationships between elements, entities, and attributes. There are some sub elements which are based on main elements in ER diagrams. ER diagrams is a visual representation of data that describes how data is to relate other using ERD symbols and notations. Following are the main components and its symbols in ER diagrams. Rectangles. This entity relationship diagram symbol represents entity types. Ellipses. Symbols represents attributes. Diamonds. This symbol represents the relationship types between these entities. Lines. It links attributes to entity types and entity types with the other relationship types. Primary key. Attributes are underlined. Primary key is the key which is mainly used to store only unique values, and it may throw an error if the duplicate value is shown. Double ellipses represents multi-valued attributes. Okay, as shown in the above diagram, an ER diagram has three main components. They are entity, attribute, relationship. What is entity? A real world thing either living or non-living, that is easily recognizable and non-recognizable. It is anything in the enterprise that is to be represented in our database. It may be a physical thing or simply a fact about the enterprise or an event that happens in the real world. An entity can be replaced a person, object, event, or a concept which stores data in the database. The characteristics of entities are must have an attribute and a unique key. Every entity is made up of some attributes which represent that entity. Examples of entities: person, uh, employee, student, patient, place, store, building, object, machine, product, and car, event, sale, registration, renewal, concept, account, course. Entity set: an entity set is a group of similar kind of entities. It may contain entities with the attribute sharing similar values. Entities are represented by their properties, which are also called attributes. All attributes have their separate values. For example, a student entity may have a name, other name, age, class as attributes. Strong entities are those entity types that have a key attribute. The primary key helps in identifying each entity uniquely. This can be used and cannot accept null values, so it cannot be a unique key. It is represented by a rectangle. Weak entity type doesn't have a key attribute. Weak entity type cannot be identified on their own. It depends upon some other strong entity for its distinct identity. A weak entity is represented by a double outlined rectangle. The relationship between a weak entity type and a strong entity type is shown with a double lined symbol instead of a single outlined diamond. This representation can be seen in the example given below. So attributes: an attribute is a property or characteristic of an entity. An entity may contain any number of attributes. The attributes that can uniquely define an entity are considered as a primary key. In an entity relationship model, attributes are represented in an elliptical shape. It also may refer to a database field. Attributes describe the instance in the database. A database consists of tables. Each table has columns and rows. The columns in a database are called attributes. Example: employee has attributes like name, age, role, employee ID, and many more. There are 5 such types of attributes: simple attributes, composite attribute, single valued attribute, multi-valued attribute, derived attribute. Simple attributes that are not further divisible into sub attributes are known as simple attributes. Composite attributes can be divided into sub attributes which represent more basic attributes with independent meanings. Composite attributes are useful to model situations in which a user sometimes refers to the composite attributes as a unit, but at other times refer to its components. Single valued attribute: attributes having a single value for a particular entity instance is known as a single value. Multi-valued attribute: there are many instances where an attribute has a set of values for a specific entity, known as multi-valued attributes. Derived attributes: the value of this type of attributes can be derived from the values of other related attributes or entities instances. Complex attribute: complex attributes are formed by nesting composite and multi-valued attributes arbitrarily. These attributes are rarely used in DBMS. That's why they are not so popular. Relationship: a relationship in a database is primarily the way two or more data sets are linked. Relationships allow the data sets to share and store data in separate tables. They also help to link disparate data with each other. A relationship in the context of databases is a situation that exists between two relational databases tables. When one table has a foreign key that reference the primary key of the other table. Relationships allow relational databases to split and store data in different tables while linking disparate data items. Types of relationships: one to many, one to one, many to many, many to one. One to one, it is used to create a relationship between two tables in which a single row of the first table can only be related to the one and only one record of a second table. One to many, it is used to create a relationship between two tables. Any single row of a first table can be related to one or more rows of second table. Many to many relationships that create a relationship between two tables. Each record of the first table can relate to any other record in the second table. Similarly, each record of second table can also relate to the more than one record of the first table. It is represented as n:(n) relationship. Thank you.